Hello everyone, very good morning, and today we are going to start our numericals on residues. We have studied residues and the method to solve a complex integration. Now suppose we have a function costed by z cube and a contour mod of z equal to 2. So how can we solve it? So we know that the Cauchy integral formula is f of z naught, means if a function is not netting at certain point z naught, if z naught is a problematic point, then the value of function at that point will be 1 upon 2 pi iota f of z minus z naught dz. So from this formula we can calculate the value of complex integration by 2 pi iota times of z. But if function of z is an analytic function on an inside, function f of z is analytic function on an inside, means points are lies inside the closed contour C. Like here z equal to 0, so z equal to 0 lies inside C, so it's a problematic point. In order to solve it, how we can solve it? A prime z naught, and same formula will be applied here. And if the powers of denominator have order of 2, 3, like n plus 1, so simply we do differentiation n minus 1 times if power is n in the denominator. Like here is power 2, so we will differentiate the function with 1 time, and same formula will be applied here. So you can see z equal to 0 lies inside, and here power lies 3. Okay, here only z minus z naught, so f g prime only function will be there. But if power started with 2, 3, then we have to differentiate the function. So simply use this formula 2 pi iota by factorial 2, and here is 3 in denominator, so we will differentiate the function 2 times with respect to that point, and same function, it will give the same value of the complex integration. So look here, f of z is cos z, and a prime z means first derivative function will be minus sin z, and second derivative of the function will be minus cos z, and when you put z equal to 0 here, so it will give to minus 1. Simply put values here, and you will get the value of complex integration cos z by z cube z equal to minus pi iota. It's very easy peasy once you practice it. Simply look at the function, what it's saying. If in denominator only z is there, simply you can calculate the value of complex integration by multiplying the value of function at that point with 2 pi iota. But if in the denominator it is not z minus z naught like structure, it is z minus z naught power 2, 3 except 1. Okay, so you will differentiate the function n minus 1 times. Okay, and then you will get the answer. Same process will be repeated again and again. Simply look here, here is the function. What are the singularities? Z equal to 0, 1 and minus 4. Okay, now draw the closed contour. This is the closed contour. You can see 0 and 1 are lies inside the function. So we have to solve this function. Z equal to minus 4 lies outside, so it's not a problem at point. Simply rewrite the complex integration in this form. Here also z minus 1 z is there, so by use integration by partial fraction. So a by z and b by z minus 1. When you solve it by taking LCM, you will get a minus 1 and b equal to 1. So put a minus 1 and b equal to 1 in here, and you will get these two complex integration. Here z equal to 0, here z equal to 1. Okay, so what you will do here, only power 1, here also power 1, so simply multiply it with 2 pi iota and function of value of the function at that point. So z equal to 0, here 2 pi iota and function 1. So you will get, by putting 0 in the function, what you are getting, 0 minus 2 by plus 4 minus 2 by 4 equal to 1 by 2. Here minus 1 by 5. So you are having the value 3 by 5 pi iota. Okay. The second method also by which we can solve the complex integration. How we can solve it? With the help of residue. Just we have studied the formula in our previous lecture to calculate the complex integration of the function. How we will calculate 2 pi times of sum of residues at those points. Now you can see z equal to 1 and z equal to 0 are the first order poles. You can clearly see z equal to 1 and z equal to 0 first order poles. Z equal to minus 4 lies outside the closed contour, so we are not dealing with that point. We will only deal with z equal to 1 and z equal to 0. So when you find out limit, what is residue z is equal to 1? It is basically limit z tends to 1, z minus 1 function of z is the residue of z equal to 1. So simply put, z tends to 1, z minus 1 and whole function, so it will be cancelled out and our value will be minus 1 by 5 at z equal to 1. And how we will calculate residues at point z equal to 0? So when you calculate residue at z equal to 0 is b0, है ना, यहाँ पे 0 आएगा. Here 0 will be, means it is b0 at z equal to 0. So z minus 0 and f of z, so z will be cancelled out and it is give you 1 by 2. Now put it in the formula, so you'll get 2 pi iota 3 by 5 iota. So this is another way to solve complex integration. Hope you are getting it. Now one more question we have. 1 upon z square plus 1 close contour z equal to 2. So suppose it's a circle, so we have two value plus minus iota and both are lying inside the closed contour C. So what are these? These are the isolated poles. So function of z dz will be 2 pi times sum of residues. So when you put limit z tends to minus infinite, it will be cancelled out. You will z minus iota minus 1 by 2 iota. When you put limit z tends to iota, so it will be z minus iota will be cancelled out and you will left with z plus iota. So 1 upon 2 pi iota. So when you sum up these two, you will get 0. Now another question, you have the function z upon z square minus 1 ka cube z plus 3. So you clearly see, is it pole of order 3 and it is z equal to minus 3. So z equal to 1 and z equal to minus 3 are isolated singularities. Z equal to 1 is the pole of order 3 and z minus 3 is first order pole. So you know how we are solving if function of z has a pole of order n at z equal to a, then so we have calculated the formula to find residues at that function if it is a pole of order n. So what is the formula? 1 factor n minus 1 derivative of z minus a raised to point function of z at z equal to a. So here we have pole of order 3 z minus 1. So just put f equal to 1 in the function. So 1 upon factorial n minus 1 means 1 upon factorial 2 double derivative of the whole function. So you can solve it by 1 by x method or u by v method. So z will be constant and 1 by x minus 1 by x square, and if 1 by x is constant, z equal to 1, put z equal to 1 in this formula. Again it will be differentiate, and when you put z equal to 1, we are left with minus 3 by 64. It was with the z equal to 1 only. Now z equal to 3, z equal to minus 3 is first order 4 and it is out of the control. This is our closed contour C. So it is lying outside, so simply b2 will be 0. When you sum it out, it will be give you answer. Another question we have, evaluate the real integration. We have d theta upon 2 plus cos theta, so we can convert theta form into complex z form. So simply put z equal to e raised to power I theta, dz will be this, and cos theta and sin theta will be this. So when you are putting this here, d theta will be dz upon I z, and 2 plus cos theta is, what is cos theta? Z plus 1 by z, okay, by 2. So z will be cancelled out with here, and we are left with this minus 2 iota by z square plus 2. So we can continue it. So we have here z square plus 4z plus 1. So it is giving us two values, minus 2 plus under root 3, it is minus 3.732 and minus 0.268. So it is considered as z1, it is considered z2. So you have 2 z minus z1 and z minus z2. Simply solve it integration by parts and get the value of limit z tends to z1 and limit z tends to z2. Now if this limit exists, then we will say it is nth order pole, and if n is 0, then we can say it is removable singularity. We have studied it earlier. What is happening here? If limit z tends to z1 and z minus z1 raised to 1 f of z exists, then it is nth order pole. Otherwise, if n is 0, then it is removable singularity. So first solving it, minus 2 iota, only minus 0.268 is lying inside. So z equal to z what is lying inside and it is lying outside. So it has no use for us for now. Means in calculation we will not consider it. We will only pay attention on this problematic point. So this, and how you are solving it is power is 1. So simply 2 pi iota function f of z upon it. So it is giving the value of the whole function 2 pi iota into 1 by 4. And in our complex integration, minus 2 iota was there. So just multiply it with minus 2 iota. So you have the value pi. Thus you can solve it complex integration by using residues in our formulas. Now we have 1 by x square. So function of x can be represented by px by qx. And you can solve it with this formula. You can put the limit of the half semicircle, real semicircle. Now it is 0 to infinity here, but here we calculate minus infinite to plus infinite, and since it is an even function, so you can simply put 1 by 2 0 to infinity f of x dx. So 1 by 2 will be there. We have already solved this integration in our previous classes. Now it is again cos z by after z square. It's also an even function, so you can put 1 by 2 here also, or you can convert it in iota z form, e raised to power z form. And when you open it, cos z plus iota sin z, so it will give you real part and it will give you imaginary part. So the real part was there, so only IR will be taken in consideration. Okay. And since it is an odd function, so it will give you 0, but here cos x is even function, so when you solve it, it will give you pi by e answer. You can see some questions I have solved, not purely, but it's like hints to solve these integrations. You can solve it in as your homework. You can find out residues and the value of their complex integration on the basis of these. Now take, this is very good form of sin 2z by 2g. If you put z equal to 0, then it will give you 0 by 0 form. So you can say it's power of order 2, but it's not the case. Just open it by putting 2z equal to 3 and you will get z equal to dt. So you are having 4 upon sin t upon t square. Okay, now when you are getting limit t tends to 0 and t1, not t2 applying here, we are using the order 1 to the So how you are solving? Limit t tends to 0 sin t by t, and it is giving you value finite, means limit is existing with order 1. So it is pole of order first, not pole of order 2. This must be taken into consideration. So you have very deep understanding about the limits and the whole process of solving the complex integration. Then only you are able to solve the MCQ type questions. So you can say here it is looking at z equal to 2 is pole, means order pole of order 2, but when you are opening it, it has giving you pole of order first. Now you can see here it is z minus 1 raised to the power 2. So z equal to 1 is second order pole. So residue will be calculated. Z equal to 1 is 1 upon factor n minus 1, n minus 1 derivative of the whole function. It will give you value e. Similarly, you can solve it with z equal to minus 1. It is an isolated singularity because limit is existing. It's an isolated singularity of pole of order 2. Pay attention on these points also, because in MCQ he can ask you directly about the singularity, types of singularity. Similarly with this function also, z cube minus z square, z equal to 0 and z equal to 1. So limit z tends to 0, z equal to 0. It is giving you minus. Very careful about sin z upon z square, okay, because it gives you pole of order 1. Pole of order 1. So it will be calculated as 2 pi r tan function of 0, and the whole complex integration will be calculated. When pole of order 1 is there, it will be very easy for us to calculate complex integration, because by simply putting this formula you get the value of whole complex integration, whereas in residues you have to calculate residues on both points and then you will sum up. Here we have cos hyperbolic pi z, and these are the first order poles. So simply check the limit exists or not. So limit exists, and here also limit exists. So 2 pi iota, and this will be giving us residue. So only answer will be left. Okay, so when you expand it, just remember that residue is the multiplication of 1 upon z minus 1. Okay, it's not like you are doing the second order fall, so you will take consideration b2, third order fall, so you will take consideration b2. It's not like that. Residue is always multiplication of 1 upon z minus 1, z minus a. Here again theta form, so you will do convert it in iota z form, put here, and you will get like this form. We have solved this question earlier in the first question. I think this was the first question we solved. So you have this, so z will be there, and z and z will be cancelled out. So 4z plus z square plus 1, 4z, z barabar 1. So you have minus 2 plus under root 3 and minus 2 plus minus under root 3. So these are fourth root, है ना, 2 and 2, fourth root will be there. So problematic point are these are the problematic points. So pole of order 2, 2 pi iota sum of residues. So pole of order 2, so solve like this, and when you are doing the same process that I explained you earlier, you will reach at the point this. Take one more question. Convert cos theta to cos theta, cos 2 theta equal to 2 cos square theta minus 1. Okay, now put z equal to s to power theta and solve it. You will have a structure like this. So you are having 2 0 second order fall, because not sign is there. and when you solve it, it is give you 1 by 2 and 2. So it is first order fall, it is second order fall. So solve second order fall first. So 1 by 2 by 2 iota from here, and first derivative of the whole function, so it will be cancelled out. And when you differentiate this, you are having the value minus pi by 8 iota. Similarly, when you solve it, 2 pi iota multiplied by function at 1 by 2, you will have the value 17 by 24 iota. And when you solve calculate the sum of the both reciprocal multiplied 2 pi iota, you are having the value 17 by 24. This I explained to you because limit is infinite to 0 to infinite, so it give you minus infinite to plus infinite, so just put 1 by 2 here. Here also you will convert it in complex form, so it will be p by q form, and you have four values of z. So put z1, z2, z3, z4, and you will realize only z1 and z4 minus and plus minus will be here, and minus minus will be here, and plus plus will be here. So only in z1 and z4 are lying inside the closed contour C. So these are the first order falls. So calculate their values of residues and put here and sum up, you will get the answer. This is the question. So p by q form. So pi by 2 will be simple pole. So calculate value of this integration. Simply limit, and it will give you residue, and multiply it with 2 pi iota, and you will get the answer. If you are calculating residue, remember to multiply the value of residue with 2 pi iota. Okay, then only you will get the answer. This is the p by q form, x form. So convert it in t form, which will lead to finally this integration. You have fourth value of z, and only under 2 by iota is lying inside the closed contour. So calculate residue and multiply it with 2 by iota. Have a look at this. You can also check from here, like if you look here, answer is z equal to pi and second order fall, but you know sin z is there. So there are two ways. If you put limit, it's z 0 by 0 form, and if you expand it as we explained earlier, means sin z by z form will give you first order again and again. How you are getting it here? Simply sin x 180 minus theta is also sin theta, to put it here, and take minus. So sin z minus pi, it will be cancelled out, and z pi will be first order fall. Okay, sin theta by theta square, when you expand it, you will get first order fall. Simply here, let us give iota 2n plus 1 pi, because you have to put minus 1. So cos 180 is minus 1. So cos 2n plus 1 pi, cos odd values of cos 3 pi, 5 pi, 7 pi, here like this. It will only possible if you take odd points. So it is 5 by psi z, and when 5 by psi z is there, you will do phi z by psi z prime, and you can see pi out and minus pi out inside. So you will put the residue at both point, and you will get the value of the integration. Thanks for being with me. Please, next class we will solve complex integration. Thank you very much.